So the question was, how do you know which one's first? Which one's male? Which one's P1 and which one's P2? The bottom line is it really doesn't matter. You could typically the first one is P1 and the second one's P2. Or the first one's mu1 and the second one's mu2. But depending on the wording, you could have depending on which one you pick, you could pick one. You're saying that the males are greater than the females. So whichever one you pick for that one should be greater than the other one. So if you pick your males to be P1 and your females to be P2, then you say P1 is greater than P2. If you do the other way and decided that your females are P1 and males are P2, then you say that P1 is less than P2.
Yeah.
So you can do either one, and you might end up with a right tail test or a left tail test, depending on which one you pick for which one. But it doesn't matter because you'll end up with the same result either way. All right, there's something we should go over last one. Let me show you something. First of all, so a lot of you guys are having issues calculating these test stats. So I can use stat test. What do you think it would be for these ones we're doing right now? How many samples do I have? One or two?
Two.
Two. You think it's a two-sample Z-test, two-sample T-test, or two proportions?
Two proportions.
Two proportions. They're proportions. Everybody follow that?
Yes.
So I'm going to go down there. And then it tells me once we put in X1. So we had, what did we have? We had 17 out of 24. Was that it?
Yeah. And the first
Yeah,
one,
the first one.
12 out of 34.
12 out of 34. 12 out of 34. And the next one was 17 out of 24. And I wanted them to be differs. So okay, so guys, take a look up here. I want to look up. See where this says how this one is dark, and I want this one instead. Go over to the one you want and hit enter, and all of a sudden it'll start being dark on that one. If I wanted the greater than, then I'd go over here and hit enter, and all of a sudden that one would be dark. So everybody kind of follow? Pick your H1. H0 always equals. So pick H1 and click on that one, and then do calculate. And this will give me my, oh look, they got 2.666, so 2.67. They got something slightly different. So if you did this one, you got negative 2.67, then that's fine too. Just gotta let me know that you did it this way. That way I know you got something kind of weird. But it's because they didn't round. They didn't round their p hats or their p1 or p2 or anything else. But for yours, you can do the same thing. The question for yours is a couple things. So first of all, the more than 5 days per week. So am I comparing something to be greater than 5 days or less than 5 days? Is that what I'm doing? What kind of problem is this, guys? Take your neighbors, talk for 5 seconds. What kind of question is this?
Proportion?
Simran, what kind of question is this? Proportion. Me. All right, Andrew, what kind of question is it? Proportion. How do you know? It has some percentages in it, right? The 5 days a week is the question you're asking people. Do you work more than 5 days a week? Do you work more than 5 days a week? Is it one of the problems, you guys, focus. This is going to help you on your exam. Is it one of the problems where I've given you a number and said 12 out of 34, or is it something where I've just given you the percentage? Which one is it? Everybody look up. This right here is the percentage. We've just given it to you. So everybody understand that? It's not 0.07 of a person out of 100. 0.07 would be that, like their hand. My hand says yes, the rest of me says no. Right? It's not 0.07 of a person. It's 7% of all of them. Do you guys get what we're saying? So it's 7% of how many? 7% of 100. So that would be. So how do I figure out what that is? Okay, so remember, our p hat is equal to x over n. Everybody on board? So that means if I rearrange it to multiply both things by n, I'd get p hat times n equals x. Do you guys know what I'm saying? So if I have this, and I have that, I can find that. They've given us, we know that 0.07, 7%, equals x over n. X over out of 100, right? So we know that 0.07 times 100 equals my x. So that's what you put into the calculator. Please note, if I put, for some reason this works out to be like 21% of 120, and you get a fraction of a person, like 26.8 people, let me show you what happens if I put 26.8 people in there. Stat test. I'm going to put 11.8 people, and I'm going to do this test. See that error? You can't have 11.8 people. You got to round to the nearest person. Everybody good with that part? Okay, so when you do this stat test, it's got to be whole people. You got to make that 12, round to the nearest whole number. Okay, go ahead. Continue on. Oh.
0.09 is not the same as 0.9.
Do you have to write the whole claim? That's hard. I was like, I'm left-handed too, like I'm already at basic random. My handwriting looks so ugly, like I thought.
But you hide it, you didn't hide it this year.
Alright, guys,
I'll explain fast.
listen up.
Okay, so which one?
Kimmy's going to explain what you did. Kimmy, go ahead.
Okay, so
You guys quiet.
p hat 1 and p hat 2 were given to us. 7% in decimal form and 11% in decimal form for male and female. Oh, yeah, and then p bar is 7 plus 11 over 100 plus 100 equals 0.09, and q bar is 1 minus p bar, so 0.91.
Great.
Then step 1, h naught equals p1 equals p2, and then h1 is p1 is less than p2, so use the words claim, well that's the claim, and then use the word support.
Great. So P1 and P2, how'd you figure out, this is from the percentage of males is less than the percentage of females.
Yes.
See where
And then
you got that part?
because I used male for p1 and then female for p2, so. But if you picked female for p1, then it would be the opposite.
Yeah.
And
And then
then-
P1 is greater than P2 if you've done that. But
And
I
then
didn't think anybody did that.
CV according to the table, which is the bottom row, because it's a proportion is negative 2.327.
Do you guys hear that? So it's just the bottom row because it's proportion.
And then I did the TS, which is 0.07 minus 0.11 over the square root of 0.09 times 0.91 times 1 over 100 plus 1 over 100, which is negative 0.988, which I put on the picture.
Great.
And then you do not reject because it's not in the shaded area. And then 5 is there's
Oh,
not.
don't forget, don't reject H naught.
Oh yeah.
Give me that part there.
Yeah, sorry. And then 5, there's not enough evidence to support claim that percentage of males who work is less than the women, yeah.
Good. All right. I'll give you guys a minute to talk to your neighbors about this one.
It's so nice in my handwriting.
Big W.
Better than mine.
Yeah, I know.
Well, we're already
That's what I do.
I had everything negative 0.7. I got like negative.
Square root?
Yeah, so
Right, so it's those two, it's never,
Oh, that's not right.
yeah. Do you think I did too much? Like maybe.
Yeah, I would have. It might have just square rooted that, I'm not sure. Oh, it only square rooted the 0.09, it didn't square root everything else.
Oh, so how can I like?
Find the inside first and then square root it.
Okay, okay.
This one I broke. So it's shorter.
Okay, seems like people are done talking, so we're gonna go ahead and go on. I want to talk a little bit about two means. So we just did two proportions. You can also do two means. There are some assumptions. Andrew, go ahead and read this part.
Assumption. Both samples are random samples. The samples must be independent of each other, that is, there can be no relationship between the subjects and the samples. If the sample size is less than 30, populations must be minimally or approximately normally distributed.
Great. So samples are independent. That means you take a sample, and then disregarding that sample, you just randomly take another sample, and they have nothing to do with each other. That's what we're going to talk about first. Two independent samples. It's very similar to the previous stuff. You find the difference between the first sample mean you take, and the second sample mean you take, and you subtract them, and then you subtract what you expect. The first population's mu minus the second population's mu. But again, you expect that difference to be 0, so that part goes away. And then you divide by the standard deviation of two samples, which is when you find the variance and add them, and then take square root of that. So that's where that bottom part comes from. Remember, your book is going to use degrees of freedom equal to the smaller n. You have two samples, right? N1 and N2, two sample sizes. Take a smaller n, and you subtract 1. That's what your book uses for the degrees of freedom for this one. Here's an example. And we all good, read?
Researchers conducted trials to investigate the effects of color on creativity. Subjects with the red background were asked to think of creative uses for a break. Other subjects with a blue background were given the same task. Responses were given by a panel of judges. Researchers make the claim that blue enhances performance on a creative task. Test the claim using a 0.05 significance level.
Great. All right, so first question is this a hypothesis test or a confidence interval? Do you see the words confidence interval here? No. Do you see the words estimate? No? No estimate? It's a hypothesis test. Do you see the words where it says test the claim?
Yeah.
It's a claim. It's a test. Do you guys see that? Next, is it a proportion or is it a mean? Nolan, what do you think? Proportion or mean? What do you guys think? Do you see the word mean or average there?
No.
Do you see the word mean in disguise?
The bottom is like
Yeah, I see X bar.
I mean,
Everybody see that? That's how you know it's a mean problem. Everybody on board? This is a mean problem. I have two of them. What's my claim? My claim is that, let's see, blue enhances creativity. So which one do you guys want to be red? Do you want this to be mu1 or mu2? U1? Great. U1, mu2. So we're saying that blue enhances creativity. That means my claim is going to be that mu1 is less than mu2. Everybody on board? If you pick it the other way around and said this was mu1, then you'd say that mu1 is greater than mu2. You can do either one. It's okay. Everybody all right with that part? Okay. So then I need to figure out what my H0 and H1 are. H0 is always, always, always that they're equal. So you guys are writing this down, right? mu2. H1 is going to be my claim. U1 is less than U2. I'm going to go over a couple minutes. Sorry, guys. Step 2, my critical value. This is going to be one-tailed. How do I know it's one-tailed? Because it's less than. Less than or greater than is the one-tailed. Equal to, not equal to is my two-tailed. So I'm going to draw a little picture over here. Less than, left-tailed. Find my critical value. I'm going to use the smaller end, 35. So my degrees of freedom is going to be 34. And I'm going to say, look at my table, and oh look, it only goes to 30. 30 and 40, so I got to use 30. Degrees of freedom 30. What about my alpha? I don't see the word alpha there. Do you guys see the word significance level?
Yeah.
That's your alpha, same thing. One-tailed, 0.05, degrees of freedom 1.697. Negative.
Or isn't it also negative or positive?
No, it's one-tailed.
Oh yeah.
And double check this, make sure I'm right. Why does it say that one? Messed up. Left-tailed and alpha is one-tailed. Oh, I changed the problem. Okay, no worries.
Why does this one have the
Degrees of freedom because it's a mean. Great question. If it has a mean, it has a degrees of freedom. Proportions, no degrees of freedom. Only mean has it.
so the first example that we did,
Was a proportion.
Now we're doing this.
So now I'm going to do my test stat, which is going to be my x bar 1 minus x bar 2 over square root of s1 over n1 plus squared plus s2 squared over n2. Maybe I'll put little parentheses around it so we can see the squared part. But, so what's that going to be? What's my x bar 1? 3.39 minus 3.97 over square root of 0.97 squared over, what was my n1, 35? What's my S2 squared, guys? What's my S2?
0.63.
0.63. Square that over 36. And then, rather than do some long complicated thing, I'm going to pop straight into my calculator.
Wait, I have a question.
Yes?
Why did you do S1 instead of the last one?
Because the last problem was a proportion. This is a mean. Does everybody understand that? This is a mean problem. We just talked a second ago about how you know it's a mean, right? Because it has an x bar in it. Remember, means, we're going to use this formula instead. Okay. All right, so we're going to go down here and take a look at this. And I'm going to pop it in. So I'm going to go to stat, test. What kind of test do you think this is, guys?
Two sample
Two
v test.
sample t-test, because it's a mean. T-test.
Oh yeah.
Statistics. What's my x bar 1? 3.39. What's my S1? 0.97. What's my N1? 35. What's my x bar 2? 3.97. What's my S1? 0.63. And my N? 36.
wait, but that says SX2.
Yeah, x2, sorry. X bar 2,
Oh,
S2. You gotta put them both in there.
oh,
And what's
okay.
my test? Is it not equal to?
Less than.
Less than. So go to less than, hit enter. Pooled, always leave the pooled as no.
Okay.
Calculate. And it gets me my test stat. Negative 2.98. Everybody all right? I'm going to switch over. Negative 2.98. Am I going to reject?
Yeah.
Yeah, it's totally in the guilty range. So I'm going to say reject H naught. As long as you have your picture with the shading, you're fine. And the last step is gonna be, do I have enough evidence or not, guys?
Yes.
Yep. Is it gonna be to support or reject? What was my claim?
Support.
Support. So my claim was this one, so I'm gonna use the word support. Claim that glue enhances creativity. Okay. Do any of you guys have neat notes in here? Anybody have neat written notes?
Neat notes.
All right. See you guys on Thursday.